Good afternoon, and thank you for joining the Designing a Concrete Industrial Pavements webinar. My name is Amanda Holtz, and I'm with the NRMCA, and also with me today is Luke McHugh, also with NRMCA. A few housekeeping items. Everyone is muted. This will help control the feedback. As we go through the webinar, feel free to type any questions that you may have into the box to the right of your screen. We will answer those questions at the end of the webinar. You may download the handouts from the control panel on the sidebar. They do include a copy of today's presentation. At the end of the webinar, there's going to be a 4-question survey or a quiz. We encourage you to participate. A certificate will be sent to you, and we will register your attendance with the AIA if a number was provided. If you know someone that's missing today's webinar or missed our first webinar or any of the ones in the future that we're offering, you can have them register for the webinar on demand from our website, paveahead.com, under the Education tab. And they will be eligible, if they go that route, to receive the AIA certificate or the certificate of attendance. This is our disclaimer. NRMCA does our best to provide you with the most accurate information on the subject matter, and we are not responsible for what you do with this information. We want to say thank you to our super sponsors for making this webinar possible: BASF, Euclid, GCP, Applied Technologies, and SECA. Thank you guys again for your support of NRMCA and our online education. So these are some of the topics that we're going to talk about today. We're going to look at some introductions of who we are as an association, why we're here today. We're really going to dig in deep to the design of industrial pavements, and then we're going to look at how and why we want to optimize our designs, and then we'll finish up with some design software exercises, as well as looking at the resources that you have available to you through the association. So the National Ready Mix Concrete Association is a trade association based out of Alexandria, Virginia. We're comprised of over 1,100 member companies, which make up about 75 to 80% of the North American ready mix production. This is our NRMCA local paving team members. We're all available to assist you. Please reach out to any of us if you have any questions or need any assistance on anything paving related. Your speakers today, myself, Amanda Holtz. I'm an engineer licensed in Colorado, University of Florida graduate. I've been with the association for almost 9 years now. I cover the Southeast United States. I've had over 11 years in the industry, and then I spent some of my time doing land development before coming into the industry, and then I've worked for the past 11 years on market development. Luke McHugh is out of Pennsylvania, and he covers the Northeast region. He's had over 33 years in practice, and we rely on him very heavily for the aviation experience that he brings to the table. So again, please reach out to us if you guys have any questions or any needs in the future. We'll be happy to assist you. So this afternoon, you've joined the 1-hour webinar, Designing Concrete Industrial Pavements, ACI 330.2 R-17. So at the conclusion of this webinar, you should be able to identify the appropriate design guide to be used and understand and identify the inputs needed for that pavement design. One of the things that we will look at today is why this document was created. Since it isn't a standard parking lot, nor is it an industrial floor, it really didn't have a fit in either category. So we created a new document specifically for industrial pavements. They're design elements that are unique to industrial facilities. When you design an industrial pavement appropriately, there's many benefits, one of those being initial cost. And we will dive into the benefits of an optimized design here in a bit. Depending on your background, your opinion of who is responsible for pavement design will differ from others. So let's explore some interested parties and see how they influence the design. So for the owner should supply the type of loads as well as the frequencies of these loads. If it's anticipating that there's going to be additional vehicles over time, then a growth rate would need to be provided. The geotechnical engineer typically provides thickness recommendations based on traffic and soil data gathered. While these may be considered recommendations, civil engineers rely heavily on this as a design. So it's very important that the geotech use appropriate guides for design. The civil signs and seals the plans whether or not they're providing the actual design. Civil should be knowledgeable of the concrete design. The structural engineer, this is a tricky one. The structural engineer will typically will design the interior floor slabs, and they make it a structural slab. And many think that since the exterior slab is going to be subjected to the same loads, the same design should be used, and that's really not true. What that's going to lead to is reinforcing the exterior pavement more so than it needs to be. The contractor should make sure that there's a joint plan before paving day, and this plan should be reviewed, and any questions that may arise should be addressed before stepping on the site. Prior to 2017, this document, the ACI 330R-08, was a document that we used for all concrete parking lot designs. When looking at an industrial pavement, there's aspects of the design that are not applicable to lighter duty parking lots. Dowels, for instance, are not usually required in thinner, lighter volume parking lots, but for industrial pavements, dowels are very common. In many specifications and geotechnical reports, AASHTO is used for pavement design. The H in AASHTO stands for highway. While it may be tempting to use AASHTO because of the industrial pavements will see a higher volume of heavy trucks, it still should not be designed with the highway design method. Parking lots have much lower speeds than what is seen on a highway. Traffic patterns are more random and usually have more interior load focus. Most every type of pavement that was out there, streets, airports, floors, and parking lots all have a design manual for that specific use. Up until this time, ACI 330R-08 for parking lots was the only document that we could have used. And now we have a document specific for industrial facilities, and that's the ACI 330.2R-17, and a lot of folks will refer to it as the 330.17 guide. Industrial facilities are not a clean fit with any existing paving category. The ACI 330.2R-17 guide, it really bridges the gaps between the pavement and floors with some overlap. The type of traffic, trucks versus equipment, are a big difference between highways and interior floors. Because of the traffic and the layout, different stresses are produced, resulting in different failure methods. Industrial pavements are similar to highways when it comes to the higher volume of semi-trucks using the pavement. The construction of the lanes for the industrial site is also very similar to highway, although it usually includes more lanes paved than what you would see in an in a highway application. But the pavement at the industrial facility sites typically will experience equipment other than standard over-the-road trucks. The industrial document looks at the many different types of vehicles and equipment and their configurations. There are similarities in how floors are placed and industrial exterior pavement is done. Many of the same contractors can be used as well as the same paving equipment. And dowels are typically used in both directions, just like with an industrial paving. In the ACI 330.17 document, the use of the modulus of subgrade reaction for pavement design. This is the upward pressure that your soil is providing, and it acts very similar to that of a spring constant. And you should find this information in the geotech report. If the value is not provided, there may be a CBR value within that report, and you can get a relationship amongst the K value and the CBR in order to use the design charts. This table is taken straight out of the 17 documents using the K values. With the increase of the heavy loads on industrial pavements, there may be a need to use enhanced subgrades. So once the soils have been modified through the addition of cements or aggregates, the K value will change. These tables will provide K values to be used for design. So I'd like to put a plug in. Please join us next Thursday, April 16th, for an hour-and-a-half webinar where we'll take a deeper look at the soils and the role that they play in pavement design. And you can register for that again on the paveahead.com website under the Education tab. So designing pavements for over-the-road semi-trucks utilizes charts based on different soil values. These charts are set up with truck frequencies on the left, flexural strength, or the modulus of rupture, is at the top, and then the resulting thickness is below within the chart. You'll also find the maximum joint spacing for each design. This document provides you with doweled as well as undoweled designs for each of these scenarios. I do want to point out that this is a 30-year design. So if you're familiar with other ACI paving documents, you'll know that that is a difference between this document and those documents. So after you get the thickness from the previous charts, you'll need to work through punching and shear and bearing checks. And this is for situations where the trailer has been unhitched from the cab and placed on the small metal sand shoes. This table provides the required thickness to prevent concentrated loads from punching through the concrete pavement. So we'll use table 4.7.6 from the 17 document to determine the compressive strength needed for bearing stress applied by the trailer support. And you'll compare this compressive strength to the modulus of rupture that has been proposed for the project. When you look at the loading for a typical fully loaded 18-wheeler, the load is spread out over a much larger area and among those 18 wheels. With equipment like the forklift shown here, there's a heavy load, but it's spread over less tires in a more concentrated area. The results in this, with these more concentrated loads, can cause more damage to the pavement than semi-trucks. So when designing for a forklift or any equipment or a vehicle, you can Google the type for the specifications. For forklifts, you run through the design charts with the specifications based on a single wheel or a dual wheel design. And we'll look at an example of designing for a forklift here in just a minute. So there are examples in the appendix of the document that you can work through. And it should be noted that the designer may choose to design for one case for the entire site. In the example above, the recommended thickness would be 14.5 inches if you did just one design for the entire site. And we would see that in that scenario, the site would be over-designed. While our ready-mix producers and suppliers would love to supply 14.5 inches of concrete over 1 million square feet of surface, we've really done a disservice to the owner by speccing out the entire site at that one thickness. Evaluating each section of the site individually and speccing out only what's needed to support the traffic and the soil conditions is what we really need to do in this scenario. So we're going to take a second and look at a design here. And again, we're going to analyze, this is one example in the back of the appendix. And so we're going to analyze a loaded lift truck or a loaded forklift. So on the left side of the screen is given information for our example. This forklift has a dual and a single wheel axle. So we're going to design for both scenarios. So step one is to design for the dual wheel case. So entering table 4.7.4b, I've taken an excerpt out of that for this slide. The static, so we're going to design for a 100,000 pounds load for a static with dual wheel axle. And so that's where we're going to be, this is a scenario that we'll be designing for. We're also going to be using the modulus of subgrade reaction of 200 psi per inch and the modulus of rupture for 550 psi. And so our resulting thickness here is going to be 14.5 inches. So we've got our soil condition here. We have a dual axle, or dual wheel axle, our load, and then our resulting thickness is 14.5 inches. So we're going to do the same plan, but we're going to do it for a single wheel axle. So we have a static load with an axle load of 20,000 pounds, modulus of subgrade reaction of 200, the modulus of rupture of 550, and tire pressure of 100. Using table 4.7.4a, in doing so, we end up with a 7.5-inch thick concrete section. Comparing the two thicknesses, the critical load is produced by the dual wheel axle, and so therefore our design for that portion of the site is going to be 14.5 inches of concrete. So jointing is very important to the successful performance of a concrete pavement. One type of joint that's commonly found is the isolation joint. Isolation joints are created by placing isolation material between fresh concrete and any existing structure. This material allows the concrete to move independently. A contraction joint is often called a control joint, and these joints are ones that we control, and they're used to control cracking. I often refer to contraction joints as pretty cracks. For conventional saws, contraction joints are cut about 1/4 to 1/3 of the thickness of the pavement. So if you have an 8-inch thick pavement, you should be cutting a minimum of 2 inches. Timing of these cuts is important to minimize the cracking. For standard saws, joints should be cut within 8 to 12 hours after placement. If you're going to use an early entry saw, cuts should be made within 3 hours after placement, or 1 hour to 2 hours after finishing. Construction joints are butt-type joints that occur where 2 different placements butt together. There's no load transfer naturally at this joint, and so in areas where we have higher volumes of truck traffic, dowels will be needed to help with that load transfer. Load transfer is needed in areas with higher frequencies of truck traffic. The devices minimize pumping of the subgrade, which in turn minimizes erosion and faulting. Dowels can have a direct impact on the thickness of the pavement. Construction methods should include proper positioning and alignment of the dowels and proper consolidation of the concrete around those dowels. Round dowels should be placed no closer than 12 inches from the intersection of any joints, which are the location of maximum movement caused by shrinkage. For square dowels, these are cushioned on the vertical sides by compressible material or void space, which permit horizontal movement parallel and perpendicular to the joints. Plate dowels are commonly used in construction and contraction joints for heavy-duty pavements, and they can minimize shrinkage restraint by having compressible material on the vertical faces with a thin bond breaker on the top and the bottom of the dowel. Tie bars can be used to minimize panel sliding, but in some cases it's really not enough. And so lug anchors can be used to minimize panel sliding. And the panel sliding can be due to fine grade, subgrade soils, steep pavement grades, and forces of braking or turning by heavy vehicles. At the joints, the panel slides may result in wider openings. It can reduce stability, and it can also cause failures in the sealants. So many industrial pavements experience equipment with wheels that are other than the conventional pneumatic tires. And these vehicles can cause higher contact stresses to the joints, and they can result in severe joint deterioration. In severe cases, such as for tractor vehicles or where steel blades or buckets are used, the joints might need to be armored with studded steel bars, or other means such as an angle iron with shear connectors or epoxy composites to reinforce the concrete at the joints. So joints are typically sealed for 2 reasons, and that's to keep the water and incompressible material out of the joints. There's a lot of debate whether joints should be sealed, but there are 4 applications where joint sealing is always recommended, and that's where you may have fuel or chemical spills that might contaminate the soil. Anywhere that you have temporary ponding zones around storm drain inlets, when needing to minimize adverse effects of dow corrosion, or where small particles, materials are spilled, mixed, or stored in the on the pavement. Just really trying to protect those joints and keep anything from getting down within the cracks. So it's important that the sites are designed to ensure drainage of the parking lots, minimizing any type of ponding opportunities. Drainage plans should be coordinated with the jointing plan, and that's going to help avoid having water channel over the joints. So some concrete mixes or some concrete pavements incorporate supplementary cementitious materials, often called SCMs, into the mixes. Some SCMs that are commonly used are slag cement, Class C fly ash, or Class F fly ash. SCMs are often added as a as a partial replacement of cement to improve plastic or hardened concrete properties. Some of those benefits of using the SCMs are sulfate resistance, lower permeability, mitigation for alkali reactivity with aggregates, and mitigation of heat of hydration that can happen in thicker industrial type pavements. Admixtures can be used in concrete mixes to improve plastic or hardened properties. So water reducing admixtures are commonly used and provide a higher slump without increasing the water cement ratio. Also, higher strengths can be obtained due to the increased scattering of the cementitious particles, resulting in increased hydration. Air entrainment is also used, and it can be used to increase the resistance to the freeze-thaw cycles and de-icer salts. Air entrainment creates these pockets for moisture to fill when expanding during the freezing. Air entrainment also reduces segregation, increases workability, and reduces leading. Synthetic fibers engineered for use in concrete can withstand the long-term alkaline environments of concrete. These fibers are manufactured polymer-based materials such as polypropylene, nylon, or polyethylene. Synthetic fibers are added to concrete before or during the mixing operation. Synthetic fibers can be a benefit in both plastic and hardened states. And some of those benefits that we see are reduced plastic settlement cracks, reduced plastic shrinkage cracks, increased toughness and impact resistance, and providing energy absorption. Macrosynthetic fibers are typically at a higher dosage rate and can be used for crack control in hardened concrete or temperature and shrinkage reinforcement in some applications. Macro fibers reduce the amount of plastic and post-hardening crack formations. They're typically thicker fibers, and they're used at higher dosage rates, maybe around 5 pounds per cubic yard. And in those usage with the higher modulus of these fibers, improves toughness, resistance to cracking, and crack tightness. So another paving material that may be used in industrial facilities is roller compacted concrete. RCC is an attractive option because it's low cost, it's easy, it's an easy preparation, high volume production, takes minimal labor, high strength and durability, and its proven performance. Some benefits include economical, high load carrying capacity. It eliminates rutting and spans weak subgrades. It's excellent freeze-thaw durability. It's simple, it's fast to construct. There's no forms or finishing, and the light surface reduces the lighting requirements. So up to this point, we've explored the proper way to design a concrete pavement for industrial sites. So what are the benefits of using these optimized designs?
Okay, thanks, Amanda. So let's see why it's important that we optimize our concrete pavement designs. Okay, so here's an example. It's a 1.2 million square foot warehouse.
Hey, Luke.
Yeah.
Hey, can you make your slide full screen? We're seeing the future slides as well.
Oh, why isn't it showing? It is full screen on the other screen. Okay.
Just switch it to that other screen, Luke, to the one where it's showing full.
You see it now?
No. Here, let me show my screen and you can take over.
Okay.
Go ahead. Just go ahead and proceed.
Okay. So next slide, Amanda. Keep going. Okay, so here's an example of a 1.2 million square foot warehouse project that was done by one of our team members recently. Remember that Acetone 93 was developed for highways, so that, when you were designing with that method, it resulted in a pavement thickness that was 9¼ inches thick with a 15-foot joint spacing. Also, if I had to guess, based on all the designs that I've reviewed, there's probably a lot of steel in the mat as well. So, when you compare the cost of this concrete pavement design to asphalt, the pavement prices were so far apart that the owner's decision was pretty easy, and he defaulted to asphalt. So, but when you use the appropriate design technique, which we now know is ACI 330.2 that Amanda described, we find that the heavy-duty design is only 7 inches of jointed plain concrete pavement, which right off the bat is about a 25% cost savings over the AASHTO design methodology. By designing the employee parking lot in accordance with the ACI 330 document, which was presented last week for those of you who missed it. It's mainly passenger cars and designed for the occasional garbage truck and delivery truck. So we can reduce the drive aisles to 5½ inches thick with a 6-foot joint spacing. And then the parking spaces themselves are only 4 inches with a 6-inch joint spacing. So what you based on the revised design, the red area shows the limits. Oh, go back, Amanda. Yeah, the red area shows the limits of the industrial pavement. The drive aisles are the 2 beige color columns on the right-hand half of the slide, and parking spaces are the gray areas around the aisle. This illustration makes it easy to see that by optimizing the design, it made the concrete option more cost competitive, and in the end, it was also very attractive to the very attractive option to the owner. Okay, so let's take a look now. Amanda presented the design outlined in ACI 330.2. So let's look at the free software that's available on the next slide. So the AASHTO 93 design can be complex to understand and cumbersome to run, especially when you're trying to fit parking lot parameters into a highway design program. The concrete pavement technology Center, Iowa State, with combined support of the concrete industry, which is the Portland Cement Association, the American Concrete Paving Association, and NRMCA, developed a free web-based program that calculates the concrete pavement design for you. It has a module based on ACI 330.2, the Industrial Design Guide. It's easy to use, and if I forgot to mention, it's free. So, it's important that you register. Go back a couple slides, Amanda. It's important that you register so you can save your designs, but you don't have to. So click on the new design tab to the left to get started. Next. Okay. There are modules for parking, streets, and intermodal. So we're going to take a look at the intermodal module. The intermodal module uses an ACPA finite analysis module for over-the-road vehicles, for non-over-the-road vehicles with either pneumatic or hard rubber tires. So let's run through an example. The project level is the first screen that you see. There's a library of various vehicles, forklifts, container handlers, container trucks, and even front-end wheel loaders. You can choose more than one vehicle. For this example, I selected a container truck and a forklift. So then you click on the pavement structure tab in the lower right corner to proceed. Here we input our subgrade information, the concrete information, and our pavement structure. For the subgrade, you can put in the subgrade resilient modulus, the California bearing ratio, or the resistivity value. Most chief technical reports will provide the recommended CBR. For the concrete, you can choose the 28-day flexural strength, the compressive strength, the modulus of elasticity, or the split tensile strength. I prefer to use the flexural strength, but this example uses the concrete compressive strength. Entering your base layer, depending on where you are around the country and your subgrade soil condition, you can place the concrete directly on the subgrade or provide a base layer. In this example, we're building our concrete pavement directly on the subgrade soil. The program calculated the subgrade resilient modulus, the flexural strength, and the K value under our pavement. If you choose a subbase, then you can change your layer types up to 3. Usually I provide a 4-inch aggregate base to provide a stable and level working platform. This layer has some structural value, but very little. So then you click the design summary button at the bottom, and here's your pavement design. Easy peasy. The calculated minimum thickness is 10.3 inches based upon the vehicle with the greatest fatigue impact, and that's the one highlighted in blue. And next slide. So, and then also there was the resources tab that was down in the lower right-hand corner. We'll I'm just pointing that out to bring that to your attention, but we'll take a look at that a little bit later in some subsequent slides. So what if my design vehicle is not in the library? And it's a good chance it's probably not. So let's see what we do here. What you can do is click on the add a custom vehicle tab. So you can click on that tab there. And what pops up is this screen here. So the first thing you want to do is put in your wheel locations and coordinates. So, so on the left-hand side, you put in the number of wheels and the axle you want to analyze in the pull-down menu. I selected 2, and what you want to do is insert the center-to-center wheel spacing in inches. Okay, we're going to take a look at the rest of the vehicle information on the right-hand side. What you want to do here is put in your vehicle name, whatever you want to choose to put in there. Put in the gross weight of the vehicle, the tire contact pressure, and the tire contact area. The program only evaluates one axle. So really, it's the tire contact pressure and the tire contact area that are used in the calculation. Even though the gross weight is put in here, that will not affect the design calculations. Okay, and then the graph in the middle really just shows the wheel spacing that you input. Keep in mind that if you have a forklift with a double tire axle in the front and a single tire axle in the back, you may want to evaluate the loaded front axle and also the unloaded rear axle. Okay, so you input your subgrade information. Here I chose to put in the subgrade resilient modulus. Next, you're going to put in your concrete information. Here I chose the flexural strength. Your K value is then calculated. So now we have a K value of 150. And then we want to see our design summary. So we click on the design summary button down at the bottom. And what we find here is we end up with our design vehicle is an 8-inch thick pavement. The recommended design thickness is also an 8-inch thick pavement. And I did this on purpose so you can check with the table that is in the design guidance, table 4.7.4a. So if you're doing this for the first time, I think it's a good idea to check to make sure that you're getting all your inputs correct by checking the information against one of the forklifts in the design guide. So there you see that everything matches. We've got a 22,200 pound axle, which has for a 550 PSI flexural strength concrete is an 8-inch thick concrete pavement. So now we're going to click down to generate report. Pavement Designer generates a nice one-page summary report that contains all the values you input and the resulting output. There's a time and date stamp at the top of the page. The summary gives you the calculated and recommended undoubted pavement thickness, the joint spacing, and the stress ratio, which for the industrial model is always 50%. Next are the design vehicles you selected. The controlling vehicle. In this run, we only selected one vehicle, so that's the only one it's going to show. The allowable total repetitions, and really the industrial pavements are designed for unlimited use. There's no specific design life that it is designed for. And the pavement thickness for the design vehicle. The pavement structure, it shows the subgrade modulus and the pavement section graphic. At the bottom of the page, we see the flexural strength, the edge support condition. For the industrial module, the edge support is assumed versus no edge support. and the resilient modulus for the untreated subgrade. Finally, the design methodology is stated down at the bottom, so it's nice for reference material that you can put into your pavement design report. So that really concludes the technical presentation of our presentation today. But before we get into responding to questions, I said we check out the pavementdesigner.org resources tab. And when you click on the resources tab, you'll see some of the information available. You can either click on there's also a load more tab or a select all, which displays all the various resource links and details contained in the program. For more information on using Pavement Designer itself, you may want to watch the video, the intro video, or the jointed plain concrete pavement tutorial that both are shown on the slide here. So I also encourage you to visit our Pave Ahead Concrete Pavement Design Center for all your local paving projects, streets, parking lots, industrial facilities, trails, and etc. And there you can get help with your design or optimizing your design, cost comparisons for your paving options, including life cycle costs that factor into asset maintenance and the time value of money, and suggestions for improving your specifications. These are just some of the services that we provide for your concrete paving needs, whether it's conventional concrete for new construction or overlays, pervious concrete, RCC, or cement slurry for FDR applications. So on behalf of everyone at the National Ready Mix Concrete Association, your local paving team, and all the help that Amanda provided me today, I thank you for joining us today, and we hope that the webinar was educational, and at the very least, you now have a resource for your local paving needs. So Amanda, back to you.
All right, before we jump to questions, I just want to point out all of our future webinars that are coming up that we have scheduled so far. They're on the screen right now. If, like I said earlier, if anybody has missed one, or if you want to go back and hear one, they are on demand underneath the paveahead.com education. You can go find the webinar that you're interested in, and then you can, if it's one that's recorded, you can register for the recording. Here is our information here. I'll leave this on the screen while we start looking at some questions that have popped up. If we run out of time on the questions, we will make sure that afterwards, any questions that are left unanswered, that we will get back to you guys. Hang on one second while I look and see. Some of these were audio. So the first question that we have is, so why can't the exterior pavement design be used for the interior slab? So a lot of times interior slabs are more of a structural slab. If they're built into the structure itself, you have to deal with it separately. An exterior pavement is taking into consideration the traffic. It is being designed for the specific traffic that will be using it. And so they're really looked at pretty differently. We have different standards that we design for. Luke, is there anything that you want to add on that?
The only other thing there is that you might have different concentrated loads on the inside versus what you have on the outside pavement, higher structural loads.
All right, load transfer on contraction joints are commonly specified, but are they needed? In my experience, yes, they can be needed. A lot of it is going to depend on the traffic flow and as well as the failure methodology or the mechanism that's going to cause the failure in the pavement. But we do, sometimes you'll see where they're only specified in the cold joint or the construction joints. but depending on the amount of loads, as well as the way that those loads are carried across the site, contraction joints may need that load transfer as well. So yes, sorry, Luke, did you have anything to add to that?
No.
Okay. Is it possible to get the recording post-presentation? Yes. Look, check back with us on the education tab next week and you can get a copy. Let's see. So there was a picture showing that the depth of an early saw is D/5 to D/6, and this comment says it seems insufficient. That diagram was specific to when early entry saws are being used. Typically, an inch to an inch and a half cut is sufficient to initiate the crack with early entry saws. But in the very thick industrial pavements, T/5 or T/6 may be necessary. All right, we had a poor unlucky soul that their presentation froze. So this one I haven't had experience with. Luke or Brian, you guys might want to chime in. Do the lugs cause blowups? I have seen blowups from lugs when used on arterial roads.
Yeah, Amanda, I don't have any experience using the lugs.
Yeah, so this is Brian Killingsworth. So lugs can most certainly cause blowups, depending on how they're used. And in some situations, like the arterial roads here, most certainly those things can cause problems depending on which way the movement is occurring. So many times we might include an expansion joint in areas where we feel like there may be blowups. Sometimes when we get to toll facilities, we'll put lugs in there to keep movement of panels limited, particularly when we're using CRC pavements. So in those types of situations, sometimes we might include an expansion joint there just to accommodate a little bit of that movement, but also keep the sliding to a minimum.
All right, thank you, Brian. The next question has to deal with soils. What are methods to increase the subgrade reaction modulus apart from increasing thickness of granular fill, specifically in areas with soft soils? Well, first of all, I do want to remind you, we have a nice soils webinar next Thursday put on by Brian Killingsworth, an hour and a half, to where I'm sure he's going to really dig into this. But the short answer that I have in the presentation, we talked about, yes, you can put in the aggregate underneath the or on top of the soils to increase your K value. The other thing that you can do is cement treatments, and so that will then increase your K value as well.
Yeah,
so we will cover
so we'll cover in depth some of the other options that we have in terms of soil treatments, soil mixing, bringing in low PI soil. So there's a lot of different things you can do there. We'll cover all of those next week in our session.
Okay, the next question is jointing required in roller compacted concretes. Many times, no. When roller compacted is done, a lot of times in the locations where they are placing roller compacted concrete, they're worried more so on the durability of the pavement, and so aesthetics are not something that they're really worried about, and so a lot of times they will leave them to crack naturally. It's a drier mix, but it is a concrete pavement, so it's going to crack. But Brian and you and maybe even Luke have more experience on this, but from my experience, my knowledge, the majority of the roller compacted projects that I know of have not been jointed.
So the Army Corps of Engineers, that typically uses a lot of RCC, they don't normally joint theirs. When you get to some of the port areas, there are some areas where they will joint. It does help in terms of long-term performance, reducing spalls and things that can happen on natural cracking of RCC. But in some joint or in some settings, it doesn't make sense to joint just because of the cost of it. So it's not done.
All right, thank you. Next question. Please comment on the effect that the bond between base and concrete surface has on the potential for cracking due to restraint. What types of bond breakers do you recommend when using asphalt or cement treated bases? Brian, this may go, and I don't know if you get into this in your soils webinar, but typically we do not call out for a bond breaker if we do a cement treated base.
Yeah, and typically what you might want to do also is decrease your joint spacing to decrease or relieve some of those warping or curling stresses that you might get from the asphalt or cement treated base.
True, and but there is potential for restraint on some of those types of treated materials below the concrete. There's a lot of different ways you can break that bond. Fabrics and things like that have shown to work. Sometimes, though, those things can cause more problems than they actually help. So, to me, that really gets down to a local environment type of decision. And for those folks in the area that have done pavement design and construction for a while, particularly contractors, they have a fairly good idea of the things that work to break those bonds.
All right, Brian, stay on board for this next one because I know that you and I have had this discussion. Proper external curing of CRCP, JPCP pavements has always been a major challenge out in the field. I've heard about internal curing technology where pre-saturated lightweight material is used as the carrier to provide water to hydrate the cement after initial set, thus lowering early age shrinkage and cracking. Are you familiar with this new technology? It seems like as we lower the water cement ratio lower and lower on pavement mix designs, external water curing will not provide sufficient penetration throughout the entire depth of the pavement. Thoughts?
Yeah, so there are potential issues with curing, especially in very large placements. You got to be very smart about how you kind of lay out what you're doing, and particularly with the type of equipment that you're using, whether it's a laser type screed or it's formed placement or whatever. So there's a lot of different ways in which you need to make sure that you get the curing down properly. And if you don't, then you can end up with some performance problems. So one of the ways to get around that is to utilize lightweight aggregate and internal curing. So honestly, I'm supportive of internal curing. I think it has shown that it works quite well. And especially in pavement environments. We just simply have to recognize that what we're doing in terms of our pavement design might be slightly different than what a conventional concrete is. And that's generally the way those pavement designs are made up. They're made for conventional concrete. So we just have to understand that if we are going to use lightweight aggregates and utilize that internal curing, that there might be some considerations that we have to think about. But as a field mechanism for increased curing, lightweight aggregates and internal curing are great. It's just a matter of being able to find them in your area, and I think there's enough suppliers across the country to where they are fairly easy to find.
All right. Next question. We have a couple more minutes for a few more questions. Will you recommend designing roundabouts the way industrial pavements are designed? I would think that this roundabouts would be more of a local streets and roads type application. when you, yes, the industrial design guide does include over-the-road trucks, but I think that would be more suitable for a streets on local roads, the ACI 325 guide. And then I know that we do have other information out there specifically for designing roundabouts. So I think that the industrial guide probably, in most standard scenarios, would probably not be the guide that we would use for roundabout designs. And the next question, there is significant discussion that centers around joint treatment, i.e. sealants, fillers, or left open. Is there a current consensus? Michael, we did in the presentation, we did talk about sealing, you know, with some of the main reasons being to keep water and incompressible material out of those joints. There were 4, let's see if I can pull that up real quick. There were 4 scenarios where sealing was always recommended, and that's if you're in an area that you've got, well, I'm looking for it here. We've got potential chemicals that could go and contaminate the soils or fuel. If there's an area that's going to be a ponding zone around stormwater drainage inlets, a lot of times those will settle somewhat, and so they'll accumulate water around them. Dow corrosion is another one. Areas, one that I personally have worked on is maybe like in a situation where there's a lot of sawdust that has been created. You don't want that, and it's basically just left to lay on the ground. You don't want those types of joints to be exposed to that material. Also, if you've got like your site layout is in a more of a valley type formation, and you've got a joint at the base of that V for the valley, and you've got water flowing over that joint, those are areas that you would most definitely want to consider sealing those joints. I mean, there is some details included in the guide that will help you along with that. All right, we have one last time for one last one, and like Luke said earlier, we'll make sure that all of these questions are addressed after the webinar. Give us some time to get all the answers together, and we'll make sure that these are all answered for you. All right, it says, is it possible to dictate the desired jointing and get a revised thickness? In this particular software that we have, pavementdesigner.org, it does not allow us to go, so the design is strictly, it's pretty straightforward as far as the inputs producing a thickness, and then it will calculate the joint spacings based on that thickness. It does not allow us to kind of manipulate the joint spacing. So, all right, with that, I have that we're coming up to the top of the hour. I do want to thank you all again for joining us today. If you have any questions, my information, Luke's information is there on the screen. We would be happy to further this conversation or any other concrete pavement discussion that you have. Don't forget to join us next week, and we appreciate your attendance, and we hope that you guys have a wonderful afternoon.